Next, I'll be going over the even homework problems for assignment 4.9b. Remember that the Student Solutions Manual has the worked out solutions for all the odd problems. So the first problem I'll do is number 60. It says, for the following functions, find the antiderivative that satisfies the given conditions. So remember, for each of these, we are going to find the general antiderivative, and then we're going to plug in our initial condition. So some of the problems, you'll see little f, and then they give you what big F is. Remember that big F is the function that when you take the derivative, you get little f. The other method that you will see them writing it down is you'll see u prime, which is the derivative of u, and they basically mean the same thing. That u prime is the derivative of u, little f is the derivative of f. So our first step is to take the antiderivative of secant squared t with respect to t. So we ask ourselves, what function has a derivative of secant squared? And that would be tangent. So our answer for the antiderivative would be tangent of t plus a constant. Now we're going to figure out what the constant is. I know when I put a pi fourths in for t, I get 1 for my answer. So I get 1 equals the tangent of pi fourths plus c. The tangent of pi fourths is 1. Subtract 1 from both sides, and I get my constant is 0. I'm now going to take that constant and put it into my original function. So big F of t is equal to the tangent of t plus 0, and we're not going to write the plus 0. This second problem that we have is number 74. We're going to find the antiderivative of e to the 2x plus 4e to the negative x over e to the x. When I write the antiderivative, I am going to write it by splitting up the fraction and simplifying so that we just have e's to powers and no fraction left. So u is equal to the antiderivative e to the 2x over e to the x. So I have 2x minus 1x is just e to the x plus 4 negative x minus x would be e to the negative 2x. Parentheses dx. We're going to take the antiderivative. So the antiderivative of a sum is the sum of the antiderivatives. Antiderivative of e to the x is just e to the x. Then I'm going to end up with 4 e to the negative 2x. And if I were to take the derivative of this, I would multiply by the derivative of the inside function. But since I'm taking the antiderivative, I'm going to divide by the derivative of the inside function. The derivative of negative 2x is negative 2. So I'm going to divide this by negative 2, which simplifies to e to the x minus 2 e to the negative 2x plus c. And I'm going to put the plus c up here also. I now know when I put a natural log of 2 in for both of these, I get 2 for my answer. So what I'm going to do is write 2 equals e to the natural log of 2 minus 2e to the negative 2 natural log of 2 plus c. This one's easy. E to the natural log of 2 is just 2. This one right here, we need to use our properties of exponents. And with the properties of exponents, this can be written as e to the negative 2 times e to the natural log of 2. Notice I put that inside of parentheses. E to the negative 2 is just a constant, so I'm just going to write it as negative 2e to the negative 2. e to the natural log of 2 is just 2. I'm going to multiply this together and subtract. So if I subtract this 2, that becomes a 0, which means I'm going to add this to both sides to get my c. 2 times 2 is 4. So I end up with 4e to the negative 2 is equal to my constant. I'm going to take that constant, put it back into my general antiderivative, and I get u of x is equal to e to the x minus 2e to the negative 2x plus 4e to the negative 2. So beware anytime that you have an inside function on something that you're taking the antiderivative of, you're going to be dividing by the derivative of the inside function. We'll be doing a lot more of these next week. So I ended up dividing by the negative 2 here. Next problem is 86. They give us a velocity function and an initial position, and they want us to come up with the position function. So the position is the antiderivative of the velocity function. So the position function, s of t, is equal to the antiderivative of 2 cosine t dt. The 2 comes along for the ride. The antiderivative of cosine is which function has the derivative of cosine, and that would be sine of t plus c. I know that 0 is when I put a 0 in for t, so I want 2 times the sine of 0 plus c. The sine of 0 is 0, so I get c is equal to 0. Take this c, put it back into my general antiderivative, and I get s of t is equal to 2 sine t plus 0. I'm not going to write the plus 0, so that would be my final answer. Problem 92, they tell us the acceleration function. They give us an initial velocity and an initial position, and they want to know what the position function is. So I'm going to end up taking the antiderivative twice, and in between each step, I'm going to use the information they provided to figure out what my constants are. So first antiderivative is going to give me velocity with respect to time is equal to the antiderivative of 2 cosine t dt. Well, that's the same antiderivative that I did over here. So velocity with respect to time is equal to 2 sine t plus c. They tell me that when velocity is equal to 0, when time is equal to 0, velocity is equal to 1. So I get 1 is equal to 2 sine of 0 plus c. Sine of 0 is 0, so I get c is equal to 1. So my velocity with respect to time is equal to 2 sine t plus 1. Now what I need to do is I need to take the antiderivative of velocity to get my position function. So position function is equal to the antiderivative of 2 sine t plus 1 dt. Going to come up here. So the antiderivative of 2 sine t, the function that's derivative is sine t would be negative cosine. The negative times the 2 is going to give me negative 2 cosine t. That's for this first part. Then the antiderivative of 1 is just going to be t plus my constant. And it tells me when I put a 0 in for t, I get a 0 for my position. I get 0 equals negative 2 cosine of 0 plus c. Cosine of 0 is 1. 1 times negative 2 is negative 2. Add the 2 to both sides. I get 2 is equal to c. And so my final position function is s sub t is equal to negative 2 cosine t plus t plus 2. In the last video, I told you that, hey, if I know something's acting in gravity and I know its initial velocity and its initial position, then I can come up with the vertical motion model. And that's what problem 98 is having us do, is they tell us, hey, given gravity is negative 9.8 meters per second squared, with an object having an initial velocity of 30 meters per second and an initial position of 200 meters, come up with the position function. They also want us to come up with the velocity function, but that's one of our steps in between. Then it asks us two additional questions. What is the max height, and when does it hit the ground? Well, the max height is when you're going to see that this is a quadratic, so it's going to be at its vertex. And it's also, we should remember from semester 1, its max height is when the derivative of the position function is equal to 0. That's where we're going to have our maximum. And we can set our function equal to 0 to figure out when it's going to hit the ground. We are going to get 2 times, because it's a quadratic. We're going to have a plus or minus in there. Well, one of our times is going to be negative. We're going to throw that one out. And then we're going to use our positive time to get our answer. So if a of t is negative 9.8 meters per second, b of t would be the integral of negative 9.8 dt. So take the antiderivative of negative 9.8, and I get v of t is equal to negative 9.8 t plus c. They tell me that my initial velocity is 30 meters per second. So when I put a 0 in for t, I get 30 meters per second. So my c is 30. My next step is to take the antiderivative of v sub t to get my s sub t. The antiderivative of negative 9.8 t is going to be negative 9.8 t squared over 2. Add one of the exponent, divide by the new exponent. Antiderivative of 30 would be 30t plus c. And it says when I put a 0 in for each of these t's, I get 200. So my c in this case is going to be 200. So my final vertical motion model is s sub t is equal to negative 4.9 t squared plus 30t plus 200. So this form should look familiar from all the vertical motion problems we've done in Algebra 1, Algebra 2, the ones you did in physics, the ones we did in college algebra. That's where that negative 4.9 t squared comes in. Or the negative 16 t squared if we're using feet per second squared for gravity. So here's my velocity function, and here's my position function. So it wants to know when it reaches its maximum. Well, in Algebra 1, the way we find where this reached its maximum, we'd use negative b over 2a to find the time where it reached its maximum. And is that what it wants? It wants us to find the time when the object reaches its highest point. Well, the time where this reaches its highest point is at negative b divided by 2a. Okay? Well, look at that. The other thing that we know, it's going to reach its maximum when its derivative is equal to 0. Well, its derivative is going to be equal to 0. I'm going to get a negative b, that's going to bring it over there, divided by 2a. It's the same function. So if you remember your Calc 1, all we're going to do is we're going to set our v of t equal to 0, and we're going to solve it. So I have 0 is equal to negative 9.8t plus 30. Subtract the 30 from both sides. Divide by 9.8. By negative 9.8. And stick that into a calculator. And the time for it to reach its maximum height is negative 30 divided by negative 9.8, which is 3.06 seconds. The other thing I need to do is I need to figure out when it hits the ground. It hits the ground when its position is 0, which means I have a quadratic equal to 0, and I can solve that quadratic by factoring, completing the square or the quadratic formula. To me, because I have a decimal with two other things, I'm not going to be able to factor it easily. So what I'm going to do is I'm going to use the quadratic formula. And I'm only going to need the positive side of it. So when I use the quadratic formula, instead of me doing negative b plus or minus the square root, I'm going to just do negative b plus the square root. Let's see, divided by 2a. I'm going to do both because it may be minus the square root. So I'm going to write negative 30 plus or minus the square root of 30 squared minus 4 times negative 4.9 times 200 all over 2a, which would be negative 9.8. I'm going to do the part underneath the radical first. So I get 30 squared minus 4 times negative 4.9 times 200. Take the square root of that. This is 4820. So the square root of 4820 is 69.43. What is 69.4? Yeah, we'll put 43. So I have negative 30 plus or minus 69.43 over negative 9.8. So I'm going to do negative 30 minus, and then divide. So negative 30 minus my answer equals divided by negative 9.8. That gives me approximately 10.1 seconds. And here, that was an exact answer. This one is an approximate answer because it required rounding. I didn't do the plus, because if I do the plus, I'm going to end up with a positive, and a positive divided by a negative is a negative. So that's why I only did one of the actual calculations there. So I know you have another problem like this. You're going to use the same format to do this problem. And a reminder, all of the odd answers are in the student solutions manual.